A curve has equation y equals x cubed minus 6x squared plus 16. A. Find the coordinates of the two turning points. Turning points are points on the graph where the line completely changes direction, and at these points, the gradient is equal to 0. So this means that we can find the coordinates of these points by finding the coordinates where the gradient is equal to 0. The gradient is denoted by y dash or dy over dx, which we can find from the equation of the curve. We can find dy over dx from y by differentiating, that is, dropping the power and minus 1 to the power. So we drop the 3 in front and then we do 3 minus 1, which equals 2. Then we drop the 2 in front and then we do 2 minus 1. For 16, there is no x term, which means that the differentiation is basically 0. But if you want to think about it, 16 is the same as 16 times x to the power of 0. So if you drop the 0 in front and then minus 1 to the 0 so that the power becomes minus 1, it's multiplied by 0, so eventually it's going to be 0 anyway. So this means we have dy over dx equals to 3x squared minus 2 multiplied by 6, which is 12, x plus 0, or dy over dx just equals 3x squared minus 12x. To find the turning point, we know that at the turning point, the gradient is equal to 0. So this means that dy over dx, which equals 3x squared minus 12x, must equal 0. This means that to find the coordinates, we need to solve the equation 3x squared minus 12x equals 0. We can solve this equation by factorizing or by taking the 3x outside the bracket. This becomes 3x multiplied by x minus 4. This means that we have two answers. One answer comes from 3x equals 0, so this will get you x equals 0. The other answer comes from x minus 4 equals 0, and this will get you x equals 4. So the x's you solve for from this equation correspond to the x coordinates of the turning points. But we still need to find the y coordinates. So to find the y coordinates, we need to substitute in the corresponding x coordinates. For x equals 0, we substitute x equals 0 into the equation of the curve. To find the corresponding y coordinate for x equals 4, we do the same thing by substituting x equals 4 into the equation of the curve. And now we have the two coordinates corresponding to the two turning points, 0, 16 and 4 minus 16. B. Determine whether each of the turning points is a maximum or minimum. Give reasons for your answers. There are altogether 3 methods that we can use to find the nature of the turning point. We will cover 2 methods in this question. The first method is to find d squared y over dx squared, which determines the nature of the stationary point, whether it's a minimum or a maximum. If d squared y over dx squared is positive, it means that it's a minimum. If it's negative, it means that it's a maximum. And we can find d squared y over dx squared from dy over dx if we differentiate dy over dx again. From part A, we already know that dy over dx equals 3x squared minus 12x. So to find d squared y over dx squared, we just need to differentiate it again. To use d squared y over dx squared, we substitute in the x coordinates of the turning points. We know that our turning points are at 0 and at 4. So firstly, for x equals 0, we substitute x equals 0 into d squared y over dx squared. This gets minus 12, which is negative, therefore at x equals 0, it's a maximum. At x equals 4, we can do the same thing. So by substituting x equals 4 into d squared y over dx squared, we get positive 12. This means that it's a minimum at x equals 4. The other method we can use is by checking the y coordinates beside the turning point. If the turning point is a maximum, this means that the y coordinates that are beside it must be less than its y coordinate. Or if the turning point is a minimum, then the y coordinates of the points beside it must be more than that turning point's y coordinate. If we check the coordinate 0, 16 first, the coordinates that are beside 0 are minus 1 and 1. To find the y coordinates corresponding to minus 1 and 1, we must substitute x equals minus 1 and x equals 1 back into the equation of the curve. So the coordinates that are besides 0, 16 are minus 1, 9 and 1, 11. 16 is bigger than 9 and 16 is also bigger than 11. This means that the coordinates 0, 16 must be a maximum. If we check for the point 4 minus 16, the coordinates that are beside 4 are 3 and 5, so we need to find the y coordinates corresponding to x equals 3 and x equals 5. The y coordinate at 3 is minus 11 and the y coordinate at 5 is minus 9. Minus 16 is less than 11 and minus 16 is also less than minus 9. This means that at x equals 4, it's a minimum point.